All right, so good morning. We'll get started. We're going to probably have people ramping in over the next few minutes, and that's fine. My name is George Neese. I'm going to be your facilitator, coach, mentor, trainer for this session. Essentially, a overview, some best practices, a lot of hopefully goodness for folks who are either already in the world of microservices and for sure for those of us who are just getting started. So again, my name is George Neese. Feel free to connect with me on LinkedIn if you're a LinkedIn person. There is no requirement that you be on LinkedIn to do microservices or any other architecture pattern. And of course, microservices is part of what we would think of in not only application modernization, but cloud native in many cases, and quite a few other things that we're going to discuss and drain over the course of the next roughly hour. So we'll probably chat for about an hour, and then we'll throw it open to folks for questions. And if not, you know, if we don't have a significant number of questions, we'll give you back a portion of that 90 minutes. Anyway, so welcome. We've got it looks like a couple of hundred folks on, which is great. I think we're originally targeted for somewhere around 500, so we'll see how many we actually get. And of course, this is specifically for all of our friends from the Amdocs organization. So welcome, Amdocs. And of course, I'm George Neese from WebAge Solutions. So really, I mean, the first thing is what really are microservices? I mean, the whole idea here is that in the notion of moving from monolithic applications to something componentized, the idea is that we'd reduce the overhead of not only maintenance but operations. We've got microservices that are going to compose similar to what we would have had for many people who've been familiar with service-oriented architecture, SOA, really an extension of SOA in my world, because here we've got, again, this idea of some front-end application, whether that be an SPA, an RA, a FAT client, something else, is actually interacting with services, and then those services themselves actually composing to give us additional behavior. A number of ways to do that through data, of course. We can do that through, putting this into messaging of some sort, whether we're using Kafka or some other enterprise solution in terms of, things like MQ and TIBCO and lots of others. And of course, everybody and their grandmother is not only from software vendors and companies moving to Docker and containers and solutions like Kubernetes, cloud agnostic solutions like OpenStack, lots of different flavors here, and honestly quite a bit of churn or change in our world. Really, we're, in my view, we're going through our second internet age. For those of you who were around for the first birth of the internet, in the Netscape 1.0 days, quite a bit changing quite rapidly, and we see the same thing here. So even microservices, the expectation here is there's lots of good, bad, and indifferent that can come from a microservices architecture. So we're going to drain a bunch of that. So microservice, basically producing an API. The API itself can allow us to, through a management platform or through an API connect or an API gateway, depending on how we route these, right, and how we package them, because we can be packaging these into containers and having a cloud management platform, an OpenShift, a Kubernetes, a Swarm, a Mesos, lots of different ways to do that. So the idea is really microservices collaborating with each other in this decentralized fashion and really aligning to small, agile teams, whether they be, it's waterfall, watergile, agile, methodology of some sort, lots of different flavors there. And of course, there's no requirement that you have to be agile to do microservices. There's no particular requirement to have a specific agile methodology. And of course, in most of the world, people are doing optimized waterfall rather than agile in many cases. So no matter where you are in the journey to digital transformation, or if you want to call it IT transformation, agile, cloud, containerization, virtualization, there's going to be something here for you, because of course the whole idea of this adoption of microservices also involves our ability to, to move to this notion of really aligning very well with continuous integration and development, tied back to lots of our EAI patterns. And of course, with microservices, we don't throw out the notion of design. We don't throw out the notion of having, some flavor of runbook or documentation. All of these things that really help us to have the guideposts into knowledge management. And knowledge management a key for the adoption of microservices, because like anything else, if you're taking, 100, 200, 500 or more internal or client applications or client-facing applications and recreating them over a period of time, do you want that to be something that goes fragmented into, 10 different silos of development and operations and management and the rest of it? Or are we trying to actually push this through to something that gives us consistency? There's governance. There's all the things that, that come from architecture and info security and all of these, different areas of the world. Essentially, microservices, when you think about it, into pipelining for CI/CD, really tying us to the Jack Welch, all heads in the game or all brains in the game. And if you're not a GE Jack Welch fan, don't worry, he's probably not on the call. So a pretty simple analogy that you see in quite a few places, in terms of the notion of composition. So what we're looking at here is really, using this idea of data processing chains, similar to what exists in a Unix command line environment. So something that anybody who's done, shell scripting, and there's similar analogies in PowerShell scripting and in most programming languages or scripting languages for that matter. So if we think about it, even into a project plan, so we have different phases leading to milestones. Those milestones then feed into, additional iterations. And so what we've got here is a pretty simple example where we're, publishing all of the CSV, Excel files in a folder. We're using our grep, regular expression checking to find any line in there with a pound sign in this case, or a number sign, and then we're counting them. So word count minus L giving us a count of all the lines that actually have these pound signs. So clearly, this is the make work, the hello world of scripting as far as that goes. But if you think about it from a microservice perspective, we have an orchestration of microservices to perform things that's in many monolithic applications would be a servlet with a set of resource servlets or resource tasks, depending on whether we're doing, chaining, or we can also do composition, because this is an example of chaining of services, but also we can have master services that are using reference microservices, and we'll talk about some of those. The idea, of course, again, when we think about it from a notion of like loose coupling or being loosely coupled, is really the idea that we're having something that blends to create patterns of use. Microservices themselves, the idea is not to recreate every application as a distinct set of microservices. It's across the set of applications we have. What is it where we can find commonality? For instance, in many organizations, a significant, somewhere between 5 and 15% by a lot of metrics from past projects and past experience. Because in my world, I've been a technology leader in IBM and an architect and developer. I've been the same in Accenture, and of course into private practice and corporate. So having worked for lots of, Fortune 500 and even some smaller companies and Global 500 companies, you see lots of these areas of commonality. So think about it, somewhere between 5 and 15% of a lot of many organizations development. Their custom software development is about creating data cleansing, sort of our MDM for each application in terms of just making sure that we have clean data coming into the app. So if we can actually create services that actually handle that, then we have a simple analogy of something that we can use as a reference, something that we can actually, use across other applications, just like we would expect to use jars and classes and libraries and, you know, DLLs and copybooks and all of these different things, depending on whether you're using any number of older procedural languages, more established, or something newer in terms of object orientation, into our world of declarative with Groovy and Kotlin and Ruby and lots of other things. So lots of different patterns here, and if you think about it, just the same as in Unix. There's many different shell script varieties. There's many versions of Unix for that matter, or Linux. And all of this creates complexity. So if I have to support every version of every app server or every browser or every of anything, I have quite a bit more complexity. The idea here is, again, with microservices, rather than having, you know, 10 or 15 or 20 or 50 different patterns within the organization, you'd look to one pattern that you can use, especially if you're supporting, you know, external vendors as Amdocs would be doing. You know, the idea is we create one set of reference services that we allow to be translated to the image patterns that each one of these specific, you know, telecom CMT vendors is using. So rather than have a set of, you know, development standards that map to a specific organization that you support, probably a better pattern over the long term, just as a suggestion, of course, and this is, you know, just George speaking from some knowledge of what Amdocs has been doing, from some of the folks we had in a workshop in Dallas this week, as well as, you know, over the course of the last few years in terms of training and working with folks in terms of learning and workforce strategy. So monolithic versus microservice. So if you look at it, each one of the boxes on the left represents a specific application server that we have spun up to handle our applications. So whether we're in a .NET world, a J2EE world, or something else in terms of this ideas of application server or some kind of centralized server technology, we're looking at every time I scale up a server, each one of these little shapes is a different service. So in, you know, more traditional development, we'll find that every time I spin up a server, I'm also spinning up, you know, if I start from the top with my little, you know, kind of plumped up comma or apostrophe or whatever that turns out to be, and I move towards the diamond, I've got an order service, a catalog service, a content service, a customer service, and a provisioning service. And each time I spin up a new server, I get another instance of that service. They all are co-located in the same environment, which means they have impact. If I'm looking to actually isolate or identify root cause, I can have services that can cause distinct symptoms and others that are going to be root cause, whether I'm in a monolithic or a microservices environment. But if you think about it, if something's componentized and it starts to run away with memory or CPU, it's a lot easier to identify who I should get on the phone. The thing is with a monolithic server application where all of the services and the front end and everything else is all packaged together, what we're seeing here is, of course, a much larger volume of people that I have to get together for unplanned work whenever something's going wrong. So, you know, hopefully not middle of the night or holiday, but everybody's phones and in the old days pagers and everything else starts to ring off the hook, as well as, of course, the emails, and depending on how your escalation works, we could be doing all hands with 80, 100, 200, you know, more than that. So all of this in terms of, you know, flavoring when we move to this microservice architecture, and this is monolithic versus microservice in a container, because I can create microservices and actually run them in a monolithic application. It doesn't mean that I can't, you know, have a similar architecture within an app server environment or a standalone servlet environment or a XE console app if I'm doing, you know, Windows microservices. All of these things, you know, we can have flavors and even have steps. So if you think about it, if I have an application that's on the picture on the left and I'm moving to the picture on the right, am I starting out with a mission critical application? What am I starting out with if I'm on the learning path? And if you think about it from my, you know, my world, workforce strategy has people aligned, essentially, you know, thinking about everyone as as really a product within the organization, because each of us have services and products that we provide to other producers and consumers who are customers, internal or external. If you think about it, each one of us can be across a volume of tasks, a circle. So starting out, a newbie in that area. We can be a square, which means we can typically work independently, but we may have things we need questions and a subject matter expert. And then in my world, the triangle is really the subject matter expert. So whether you're a circle, a squircle, a square, a squangle, or a triangle in cloud, in CI/CD, in microservices, all of that information we want to pull out to end up with this reference architecture of how we're going to strip this off. Because if you think about it, this is showing a path of moving the application into a broken set or a componentized set of services. So basically breaking out each one of these services or groups of services, because I can have affinity groups of services as well. If I'm taking a digital commerce application, am I going to break every single catalog service for product and category and catalog into a separate microservice? Or am I going to actually group them together because, of course, they tend to reference each other? So if you think about that from a catalog perspective, a catalog has products and categories. They are bidirectionally referencing each other throughout the process of flow, of promotions, of recommendations, merchandising, all of these things. So there are cases where we want to group them together. So I might take a digital commerce app that's represented on the left-hand side and break it into a set of basically microservices for catalog that are grouped together in this notion of affinity or correlation. And of course, feel free to jump in with questions because, again, as I said, I work for Accenture, which means I can essentially talk until you fall over. Can you please quote some real-time examples rather than this conceptual theory? Would help us to relate better. Well, I think, Navina, I think we probably need to just have a little bit more how microservices is different than concepts of open APIs, web services, portlets. Is it revolution or just evolution? Well, I would say revolution, so that's a great question. And unfortunately, somebody may be recording the session, which we would play back, but I actually don't know because I'm not, and I don't have enough space on my computer to do that. I think the session says it is being recorded by one of my co-minions. Have we started discussing? I can't hear anyone. I hope everyone can hear now. So if you're having any issues hearing, please call that out. And of course, good day to all. Good morning. Welcome. Rock and roll. So how are microservices different? Well, if you think about it, there's lots of things. We're talking about this notion of actually having our ability to componentize them. So from a theory, I don't know if we're going to stick with theory or the rest of it, but so far I think there has been plenty of hopefully real world that's been tied back to some of this theoretical. If you have specifics in terms of what you're thinking, please feel free to jump in on those. I'm happy to digress, and for sure we'll come back to questions further along the end. So qualities of microservices. So the whole idea of this componentization is breaking down. So hopefully that whole notion of affinity and breaking out a digital commerce app made some sense. If not, then we can sure discuss a little farther around. So organized here around the business capabilities, that's where I was talking about this essentially data management, data cleansing service. Products, not projects. Well, surprisingly, rather than having groups of Scrum teams working on large monolithic apps, we've got them individually owning specific sets of services. The smart endpoints, of course, is that the services themselves need to be aware, whether that's aware in terms of authorization based on claim-based authorization, more commonly now with JWT, and we'll talk about some of that. And of course, the pipes themselves just being either messaging or data layer centralization. And honestly, starting out and thinking about this from building out applications and services could just as easily be writing JSON files or even XML files to a file system. Because no surprise, when we start thinking about 12-factor apps and some of that tied to application modernization with microservices, we may or may not, really be looking at in this case, spending an awful lot of time creating a data model before we start to build out what we're doing for a minimum viable product MVP. And so for this notion of decentralized governance, no surprise that makes most of the people in the world who are tied to our notion of info security extremely much more busy. Because now if we're going to wrap microservices in containers, we have to have some way to inspect those. Not to mention we have to have, from an architect perspective, we have to have a reference image that we're using as the base for that Docker. We should have a reference pipeline that's showing us the building of this, the 1, 2, 3, mapping in terms of this. So when we think about this, we're gonna pull back into as well data management. So are we taking our monolith, and it's always easier if I think about this. If I'm building a greenfield app, so something from scratch, it's much easier to take it and put it into any kind of new architecture pattern, assuming that I have the time, talent, and treasure to do that, the 3 T's as it were. But the much more significant piece of most of our world, 90-some% of most people's work over the next year to 2 will be either moving brownfield apps or rewriting brownfield apps or migrating application modernization. And so here, the idea is are we looking to actually split this application into separate data models as well? Because of course, initially I may wish to spin off a couple of microservices which I extract from my monolith and then see how that runs alongside so that I have the feelings and flavor of it. Because there's a lot of different ways that we can move this forward. Again, until I have experts in the organization in the management, the use, do I throw all of my eggs in one basket and say, oh, everything will now be this new, reference technology that we really need hundreds of people to be triangles in, and we may not have more than a few currently. So infrastructure automation, no surprise, not just for the notion of spinning up a container with some kind of container management platform, the Kubernetes, the Mesos, the AT&T specific version that they've created for their AIC platform around Helm and Kubernetes, and some other different patterns that we can see there in terms of this through Jenkins and CI/CD. So of course, in all of this, we're talking for roughly an hour. So is this gonna, if you're an expert in microservices, then I won't take that away. But in an hour sitting and having me speak towards you with this deck, which we'll share, you will not be moving from a circle to a square or a square to a triangle. You might move from a circle to a squircle, as far as that goes. And again, if you're already working in this area or have some expertise, then I don't take that away from you. So designing for failure. Well, of course, everything fails. And if you think about it, if I'm going to take microservices and put them in a stateless infrastructure with containers that's being treated like cattle, where containers and pods and nodes can actually be flipped around or flipped off or up, down, sideways, I have to have a way to pull the information out, and of course I have to have ways to monitor. There's lots of different monitoring strategies that organizations can use. The thing with it, for me, in terms of view and just value add, Amdocs serves a lot of very large enterprise customers, some of whom, may already have some of these patterns. And on the flip side, anybody who isn't already implementing these patterns, as you're seeing with AT&T and their AIC platform, they're going to be looking to you folks to actually bring them guidance, reference architecture, reference frameworks. Essentially that's been there, done that. So spreading that out across the organization in a fairly quick hurry, again, bringing back this notion of knowledge management. And back to, an earlier question that I saw, the whole idea here is, of course, is that this is evolutionary. This is an evolutionary, because revolution, seriously, there's no way that any major organization can revolutionize anything literally that's steady state and working as it sits right now. How would that, if you think about it intuitively, how would that literally be possible because if you tried to do that, you'd end up turning the lights off. So here we have a picture of basically something using a broker and thinking about what it is that we're doing in terms of this, breaking out our monolith into API-based microservices, several of them with their own data store in terms of a regular, either relational or NoSQL database, one with several with no data store at all, because assumedly they're reference services that are being used by some of our others in terms of this. And then, of course, this notion of how are we brokering them together? So is that the idea of Zookeeper? Is it, some other kind of container management platform? There's lots of different ways we can orchestrate microservices, either inside containers or without containers. So that's where, all of this becomes a amount of overlap, but also the idea that at some point, somebody within the organization, some group has to take on the innovation responsibility of saying, here's our one size fits all, hopefully not, our first primary pattern, our secondary pattern, our tertiary pattern. What are these patterns? They're tied to specific ways that you're going to take an existing monolithic app and turn it into something that's more componentized. And why would we do that? Because once I run it in environments that spin up, whether they're in virtualization with VMware or VirtualBox, or they're in virtualized application containers, I'm going to optimally simplify the running, the supportability, the sustainability. A lot of it is about not removing operations from the mix, because I personally don't believe that DevOps and all of these technologies actually reduce headcount. What they do is they realign. They basically allow us to realign manual or unplanned tasks, work, to things that are going to drive competitive advantage. And of course, all organizations want that. And so when we think about this design for failure, all of this across our applications is part of the risk. The challenges that a lot of people face, we'll talk through. Risks, the complexity, we'll actually drill to quite a bit of it. So from a cloud native application perspective, because no surprise that I can end up, a lot of organizations want to keep their data within their own four walls, their primary databases, their customer, their order, they want to be able to secure them themselves. Now they're tying them back to microservices that are on-premise, as well as in this example, we actually have, somebody using Azure, assumedly using functions similar to our AWS Lambdas to act as microservices themselves, because a microservice can be a lot of different things to a lot of different people. A service is really something that I can invoke through an understanding. Now, most people would characterize the understanding as an API, but if you think about it, almost anything could be literally a piece of a microservice, not just Java or Go. We can create Python. We could actually make scripted services. There's lots of different flavors of this that come out. And so no surprise, we're showing this notion of a web app. So the web app itself is hosted as a much smaller, so we may still have our WAS, our WebLogic, our ATGs, our Tomcats, our JBoss, and I would expect most people will have them around for quite a while. We may or may not be running those in containers. We may be running those on application servers and then using services that are containerized. Because like anything else, do you put all your eggs in one basket? So here we're showing, this whole notion of I have this idea of cloud native with services. Am I actually going to be doing all of that in a public cloud or a private cloud, a hybrid cloud? Probably not community cloud per se, because that's, much less used, but one of the cloud deployment models, and very often that's going to be a mix. Again, when we start thinking about containerizing things in microservices, the services themselves will containerize very well, and small, lightly used databases could as well. You'll see many types of databases, almost every single one that you can think of, except for some of the older ones, in containers. That doesn't necessarily mean those are going to run in containers for most people in production. Because of the high input-output that's required, it reduces the ability for a lot of really highly used application components like databases, for instance, to be containerized for most organizations as they begin the journey. So the challenges, so here's the idea, right, is that all of this is supposed to increase velocity, but does it reduce quality? Of course not, and complexity, of course, tied back to this as well. The more complex my infrastructure, the more complex the application components, I may be able to use services, but quite honestly, at some point, for almost all applications, somebody has to know how all of those services are going to fit together to solve some business problem or business solution that's going to be used internal customers, external customers, and how we, see that in terms of those stakeholders and that use. So agile delivery of applications. Does that mean that I have to be using Scrum or XP or Kanban? Of course not, because agile delivery just means I'm trying to iterate. The idea is I'm trying to make it so that I can get to this notion of minimum viable product. And there are some things that we have to learn and unlearn. And of course, all of this also requires, not only as part of DevOps, it requires that cultural shift, because there is some changes here that are going to make some people very uncomfortable, make other people feel like they've just, walked into happy land. It depends on whether, you get the chute or the ladder in terms of a game like Chutes and Ladders with these microservices and cloud native specifically. Because think about it, if it feels overwhelming when you look at everything that's happening with DevOps and cloud and Agile and all of these different pieces, honestly, it should. Microservices is just another piece of the puzzle. It's another tool in our tool belt. It doesn't mean that it solves everything. It's not the silver bullet against all application werewolves. It's just one way to make things more predictable. And so that predictability of using cloud, now, not everyone is going to want to be the Netflix and putting all of their application in cloud. And the reason for that, of course, is that has a very significant expense. People who already have existing data centers may spin data centers down to take advantage of cloud, but at the same time, there's a lot of reasons why people have built those practices, and very unlikely that for most of us, we would, get to retirement and have every single company in the world in cloud. Number one, because many cases, cloud is significantly more expensive, even with considered staffing over bare metal for many people. Now, simpler, so cloud for headroom, great idea. Perfect, great use of cloud. I have my internal infrastructure that's set up as a private cloud. I then, whenever I need additional headroom for holiday or peak, I spin up into cloud, and I might be using something like AT&T's AIC in this case, thinking about it from a notion of OpenStack being cloud agnostic. Now, most organizations are not cloud agnostic, and quite honestly, if you think about it, I've got tools that'll make my mobile development, Android or iOS agnostic, but then I'm not writing native apps anymore, and I'm not necessarily really harnessing all the power of those underlying platforms. And OpenStack reduces the complexity in some ways and increases the complexity in others. So the move into cloud is not necessarily something that everybody just jumps in and starts doing. Start small, get some wins, figure out the reference framework, whether it's cloud microservices, cloud application modernization, and all of this actually blends together. So from a sustainability and supportability, think about it. At this point, we've got people who are going to want to, pull things together in terms of this CI/CD pipeline. So all types of these deployments, and of course, I can be deploying into my local, I could be into bare metal, into cloud, into virtualization, of platform, of container, combinations of all of these. All of that CI/CD piece of it is something that I now have to understand, because from supportability and sustainability, if I'm going to have a large number of applications that are going to be componentized with microservices, how are people learning that? Well, first of all, we have to develop expertise, those experts, and through project work, we take those, we turn them into what I would call the style guide for microservices, the style guide for a cloud native microservice, the style guide for cloud native app modernization, and then of course to Gold Master, which means that I've got something. So Gold Master is something people typically use to reference data for MDM, and also, of course, in terms of areas like we would think of in the building of infrastructure. So once I have a server where I want it in a VM environment, I snapshot it, and then I can actually, spin it back up, and I then have safety, right? So the whole idea here is I also want to give people the environments to make mistakes. If you're using OpenShift with as Red Hat's Kubernetes platform for a customer or internally, the whole idea here is that OpenShift expects that people will then have sandboxes, and the AIC environment encourages people to use their sandbox facility. If you happen to work with the AT&T folks, they can, or have them across the wall or across the office or across the geography, they can actually provide some of that background as well. And hopefully, for everyone else, because no surprise, all organizations are examining how they can reduce technical debt. Microservices and cloud is one of those ways. So reliability and the reduction of impact as we're making changes, because you think about it, all of us have worked in environments, or many of us, where we have to continue to update features and releases and everything from hot fixes to patches in environments that are also being patched themselves for the underlying infrastructure, the underlying platform, the IaaS, the PaaS, whatever it happens to be, and whether it's something that I'm building from scratch and off a loading dock into a server that I cable, or I turn it into virtualization, or I'm using Kubernetes or some other cloud management platform and containers with Docker, I still have this same notion of complexity. I want to make it simpler. The way to do that is through automation of many of these areas, and the automation itself and the application of DevOps to the microservices and cloud and Agile all bring this together. Because there's really the convergence. This is, there's been movies called The Convergence. There's lots of things that can converge over time. If you think about it, this is the convergence of a lot of different areas to one consistent pattern or set of patterns for each organization. Excuse me. And so, as we see in Azure, in AWS, in SoftLayer, in Rackspace, in Jenkins, we're providing dashboards, and those dashboards are going to be used for decision support. It is coming down the pipe right now for many organizations because they've seen this in action at some of their leader forums. They've seen it from other customers. They've seen it at shows, whether it be, something like a DevOps conference or a cloud conference or a retail conference or a manufacturing conference. These different ideas of trying to take people out of the work of manually creating spreadsheets to generate reports and decision support data to automating that. So then when we walk in the morning, we'll see our application project, on a TV next to the cafeteria, along with all of the great information about charities and community support and, wins with customers and individual success or team success, group success within the organization. This notion of publishing these dashboards so that everyone can see what is going well and what is not going so well. So opportunities. The idea here is also that with cloud native, I start to have the ability for self-healing. Now, is that all there now? No, not really. Because there's still a lot of things that can go wrong. And if you think about it, I'm looking to design for failure, and that means dashboards will help, digital performance management will help, or application performance management, and those tools tied into my container environment, my virtualized environment. This does not exclude, again, this is the all heads in the game, and there's places and patterns that people can use. I'm using Kubernetes and container management. Do I still use a configuration management tool, a Chef, an Ansible, a Salt, a Puppet? Very likely yes, because there are lots of different use cases here. And granted, at this point, one size probably does not fit all. We want to reduce this to less sizes fits all, because in many organizations, there's dozens of log strategies. There's many different monitoring strategies. There's different processes and tools that people are using to do the exact or very similar tasks. So if we think about it, that got a little pixelated. So if we think about it, this notion of cloud native plus agile plus DevOps, and microservices is at the heart of that, right? So if you think about it, I've got, microservices, which I'm expecting to make simplified. Why? Because I'm not running them in larger monolithic app server environments. It doesn't mean that I can't do that, because some of the, no surprise, app server vendors are trying to make reduced size containers. Because if I'm running Java in an executable jar, I'm still embedding a servlet container most of the time in that, a Jetty or some other form of servlet container to actually run this service. In this case, what I'm doing is reducing the complexity, but also I'm now using something that's maybe not as optimal as some of the server products that I've got my team already used to. And that can be, good or bad. The idea here is that I still need to have that performance. And if your organization has, or the group you're in specifically, or supporting, is already doing 100 million request, services, then you should take that and say, hey, we got something good here. Let's lift that up and show other people what it is we're doing for our organization so that they can actually have a view of it as well. And actually, some really good questions. I'll continue to try to drain them as we move along. I mean, the thing is if we're through data management going to break up services into individual, database tables, the idea is again, this notion of affinity groups. So think about it. If I have to take something that's being managed from a data perspective by foreign keys and primary keys and relationships, then I'm going to still have to have some way to seam all that together. So does this make it absolutely brain dead simple to take an existing application that might have hundreds of database tables and services? Oh, heck no. There's additional complexity there. And if you think about it, a lot of organizations use stored procedures in their RDBMS systems because stored procedures are literally flaming fast. Well, that speed sacrifices the flexibility in this case of our notion around being able to split up a lot of these these databases. So there may be half steps that we have to take. And again, this is where our development team, our architecture teams, our security teams are all, and of course our quality teams are all working together with our product owners, our business stakeholders to figure out what we can do within the box we have of time, talent, and treasure. And we will definitely talk more about best practices and some of the other pieces that we'll be looking at. Thank you very much. I do not need to see Facebook popping up. Let's do that. There we go. Now at least we won't have any of this monkey shines on the side. Perfect. So sorry, I just noticed I was suddenly being pinged by someone and I need to disable that, so that's perfect. So key components of successful microservices teams. Well, no surprise that the winner chicken dinner here for me is really the A cubed and C. And why is that? Because accountability for sure, because we're talking about service consistency and really this notion of having across our teams the injection of security and standards in our base images for our containers, our patterns around how we're coding our microservices, the infrastructure that we're standing up, the sandboxes. All of this ties back into these CI/CD pipelines, which literally involve all teams in the organization. So who owns that pipeline? Well, in many organizations, that's still under discussion. But the pipelines themselves across security and quality, and specifically into the continuous delivery, and even for organizations that are doing continuous deployment, which is not very many, honestly. So the difference, of course, continuous delivery, we're moving things to the last environment before prod, automating the risk assessment to allow that to happen, reducing the number of manual steps that we have in there, and then finally taking a breath and saying, all right, let's think about what we have here, do our reviews, our ARBs, our stage gates, whatever they are, and then push it out. Now, continuous deployment, of course, is a slightly different notion, because here we're having people check code in, we're automating risk assessment across all of these different continuous delivery environments, and then we're actually putting the code into production. Now, do we put that code into production so that everybody in the entire world can see it? Unlikely. Most organizations would put it behind some, essentially feature toggle, flag dial switch that only lets it be seen by internal stakeholders, VLAN, geolocated, some kind of switch that I'm flipping either through a tool like Fiddler or something else, but some way for us to limit the exposure. So not everything going in. And of course, then when I need to turn it on, I'm not doing another deployment. I'm flipping the switch, usually with some data component. So automation of cattle. So if we think about this, the automation of the cattle versus pets, because as we move into specifically microservice, they lend themselves very well to being put into containers. Does that mean I have to have a container infrastructure? Well, no. No, you don't. You can do microservices literally without containers, but the bang for the buck here is really to do them as containers. Why? Because then we're separating them out. We're allowing the team to own that, and the team owning it is now creating their own pipeline, which is has a Docker container that actually has their build environment for that service. They spin up the Docker container as part of their pipeline. They build the service. They put the service into another container. They exercise tests against that service, and then finally they publish it to be packaged into forward environments and finally readied or deployed directly into production. So architecture patterns. So all of this is really about reference frameworks. So when you think about it, the different ways, I mean, literally, if you look on the internet, you could find 20 different languages that you could write, and maybe more, that you could write microservices in. The Go, the Java, the, C#, the, you name it, Node.js microservice. All these different ways to write them. What is going to be the pattern that the organization chooses? And if you're the person defining that, feel free to speak up, because I'm always welcome to share the floor with anybody who brings that kind of knowledge. So other key areas in this, of course, the culture of containerization, as I mentioned, because when we think about it, not surprisingly, containers become a big deal for almost everything to do with microservices because of the componentization. All right. So what else? I think I've actually drained the rest of this. So as much as I like to continue to speak to that slide, especially when it's got the winner, winner, chicken dinner shirt. So designing for failure. So the thing about this microservices architecture is this designing for failure. We're going to talk more about this into best practices when we get a little farther along. So think about it. Any service can fail anytime. If a service is in a container and it fails, we're gonna drop the container. We're going to lose any data that was within that container. So if we're writing logs there and we're not actually forwarding, all these things that we have to consider. We also, of course, need to respond back to our client application. This detecting failure and automatically restoring service as far as that goes. This whole idea of spinning up additional containers and making sure that I have a balanced set of containers for HADR as well. And then the applications need to be monitored. So do I already have an enterprise monitoring tool that we're using, Dynatrace, some other tool that's going to allow me to not only monitor containers, but then do synthetics monitoring where I'm capturing loads and being able to play them back. A key part of a lot of these tools around DPM and APM is the ability to not only identify loads, but then to be able to replicate them based on production characteristics. So Netflix, Simian Army as well, giving us the idea, starting out with the Chaos Monkey and moving through, Chaos Gorilla. And of course, Netflix being people who really don't mind sharing a lot of what they, have, whether it's the OSS with all of the, feigns and bits and pieces, the Eurekas that Netflix is using for their own microservices, and great examples. Netflix is publishing a lot of things like Conductor as an orchestration tool for manual and automated processes in not only software engineering, but then tied to outside, because of course, not only do they have a significant volume of software streaming, but they also have production and new, TV shows coming up and all sorts of other different ways that they can have that information flowing, both through manual cycles and people and automated cycles of approval. So really looking for that whole notion of resilience. So then we get into this microservices in a nutshell. So if you think about it, this shift left piece of this is by getting people from quality and security and development and operations to speak up front about what this architecture is going to look like, you bring the ability for people to have their knowledge shared across groups. So this shift left is tied back to MVP as well, which is this notion of minimum viable products. So instead of trying to create the enterprise framework of all goodness and spending a year to do it or 2 years, we start small and we work out. Recognizing success, iterating, agile, and then as important, working to identify defects earlier in the pipeline, but as well recognizing gaps in intent, because the gaps in intent typically cost more than most defects. Gaps in intent can also tie to NFR requirements for sure, the non-functional types. But when you think about it, the competitive advantage here, well, all of this is about trying to be able to say yes to the business more often. So yes to our clients, our product owners, all of this, simplification in some instances and masked complexity means that we're actually able optimally through DevOps and Agile and cloud and microservices and reference architecture to be able to say yes to our technology-enabled business. Because we talk about this time to market and value, which is great. But really, when you think about it, time to market and value is another one of these buzzwordy things that executives talk about. And if you're executive, that's great. The idea here is that time to market and value is focused on only two things. Can I save money or make money? Can I increase the volume of customer, increase the value of customer, lifetime value of customer, customer engagement, customer experience, customer happiness, loyalty, all of these things tie back to this technology-enabled business. And why is microservices important? Because if I can more simply make changes because they're componentized and move them without having to do these giant monolithic ER releases, I'm simplifying the actual ability to move the business faster towards changes that will drive revenue. Again, technology-enabled business is not about revolutionizing the industry. It's about, if it normally would have taken me a year to crank out an application and I would have seen a $3 million lift on it, then if I can get the majority out in 6 months, am I going to be able to capture, $1 to $1.5 million of that lift that I would not have had for another 6 months in my first case? And then, of course, this notion of gold master. So think about that. This is all about a lot of the things that people in UI, UX, or even in the data management and environment space, infrastructure space, have been doing forever, which is basically creating a reference that you can use to stand up another server, or in the case of data, we've got our gold master record for customer or order or catalog. All of this tells us that this is the perfect example. This is not only the perfect example, but this is the reference, and we need that for microservices, because otherwise we're going to churn any organization that has more than 5 people. Because the thing is if you don't have the knowledge someplace that's searchable, like people will use ELK and ELF to wire up their microservices infrastructure, but they don't actually use something that's a search mechanism with metrics and dashboards to give people the access to knowledge. So if you don't, then where do they go? Well, no surprise. Google, 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 Bing, Google, Google, Yahoo, Google, Google, Bing, to the search engine, to the internet. There we go, to the Batcave, as it were. So Docker containers drive that adoption of microservices. The idea from Unix is to do one thing and do it well. Well, Docker, the reason we have Docker, the reason we have OpenShift, the reason we have Kubernetes, the reason we have a lot of these platform specifics is almost entirely because of Google. Quite honestly, Google is the #1 committer on the Docker and Kubernetes project. You know, they started it as, you know, their own internal Project 7, and no surprise, the #2 committer on both of those projects at my last look was Red Hat. So Red Hat and Docker, you can either blame them or you can thank them, but they're the ones who are actually bringing this forward. So we're aiming to do one thing and do it well. Well, the whole idea is we want to simplify, and when we start talking about containerizing microservices, we're actually making the environment more complex and having to have tools to manage that, but also we're reducing the complexity of many things around standing up, you know, different environments and the tools and the rest of it. So you want to modularize the application? Well, that's all great. We love that. That's all about application modernization. So containers and microservices in this case, enabling that ability to do continuous integration, continuous delivery. And so when we think about it, SPAs are just one type of front end. So I load a page, it sends a request, returns some HTML, and after that I'm invoking, you know, services through my front end application to my back end in Node or in Go or Java or whatever my microservice framework is, my application framework, my wrapper around services in terms of that, and I'm returning JSON more commonly now. You know, in the early days of service-oriented architecture, almost everything was XML, but XML in a Java world has a heavy footprint, and JSON goes directly into basically object-oriented classes typically. So simplifies the process, reduces the overhead. All of these things are good for performance. So Spring Boot is a really common platform. A lot of people are using Spring. There's lots of other ways to create microservices. Just in terms of these REST frameworks, RESTlet, Dropwizard, you know, lots of others, Spark, and not the Spark from Hadoop, but Spark in terms of a REST type API enabler, all different ways to write REST services. And most all of this is, you know, is focused on making services simple, and it's very hard to make anything much more simple than REST. So rather than making REST the mechanism of endless security, we rely on secure protocols, secure pipes, and then claims or authorization and authentication that we pass around. And of course, always good to think about things like OAuth 2 as we move forward. And of course, looking at using JWT, which we'll mention as well. So data management, we actually drained a lot of this. You know, this is the early on example that I mentioned. So a reference in terms of this that you can take a look at. But essentially, how are we breaking up what was one monolithic database? Are we breaking it out into 4, like we show here, or are we going to break it out into 400? And what is the business value of that? Like, is there a value in actually breaking it down to that level of granularity? In some cases, maybe. In other cases, not. And so the state in monolithic. So state, of course, becomes much more important. And no surprise with the stateless application, really, even in monolithic apps, we're maintaining state in a database or in a session. We're not really talking about having stateful, you know, servlets or anything else. And we're not really talking about stateful in microservices. It's as we're moving from one piece of the puzzle to another, how are we actually maintaining that state? And so we'll talk through some of that. So this whole notion of JWT. So if you're not already a JWT fan, then you're probably not aware, if you're doing OAuth, that it sits underneath a lot of that. The idea is that we can actually do claim or role-based authorization, and authorization itself, for most of us, is around, in monolithic applications, putting roles in a database that we then tie back into around code, which we use JAWS subjects and servers and digital trust stores and all of this, something that's would be much more complicated to maintain in a containerized world. So in containers, we're really looking at the ability to, to really have our payload be for a JWT, the claims, so in this case, telling us what our authorization is. And of course, all of that, like most things, we can go to, for almost all of these newer technologies around open source, around cloud, around, digital transformation, we're going to go to a .io website, the Jenkins.io, the JWT.io, Kubernetes.io, lots and lots of different IOs. Angular.io or AngularJS.io, I would correct myself there. So management lift, so lots of different ways that we can look at managing this. And there's great examples. What is going to be your pattern? So is it going to be based on one of your customer accounts and the way they do it? And so you're, flattering by mimicry, or is it something that's different than that? Because if you have to support a pattern that's going to be represented differently for different organizations, then you have to have the flexibility based in your base images and your base services so that you can run basically a translation to move them into their environment. Because no surprise, as people are building out these infrastructures, especially large companies, they're saying, hey, you do it our way. So service fabric, and if you think about it, we're taking a traditional monolith, we're talking about doing lift and shift, so we're modernizing by adding services that run alongside our code in containers or in applications. Then as we innovate, we start to break that monolith up, we transform more and more into our microservices model, and we gradually shrink down. It's the same thing as any type of idea where we start with a mountain and we're moving rocks. Here we're moving rocks. We're moving actionable rocks by slowly reducing the monolith. If we have the time and we don't have to keep this thing alive, we could write it as a greenfield, sure. But not everybody has the benefit of the time, the money, and the resources to do all of those things, especially not all at once. So microservice best practices. So if you think about it, this is my list, but there's lots of others. The whole point of a lot of this is really, I need a base image, so I need a reference. For a Docker image, I need to bake in my security. So that, as well as my, am I putting my ELF or ELK or Splunk or some other kind of log aggregation in there? How am I going to do conversation or correlation IDs? And so in all of that, we're looking at ways that we can create patterns that make these services more supportable. Because services by themselves can create an endless amount of complexity and really fragment the organization. So this idea of resiliency, for creating, again, telemetry in our base image so that all services speak the same language, output in terms of that. Service identification. I'm using one great example is to use that user agent property to actually set the name or the logical ID. And then, of course, back into this whole notion of having a reference architecture. So there was all we had for this day. Of course, we'll be providing the deck. I think I've drained a giant piece of this, but let's see. Does the broader responsibilities of DevOps approach mean more work for developers who constantly have to think about the bigger picture? Possibly, but really, it's not just on the developers, because this is really in all heads in the game. It's not that we're teaching developers to be info security people or developers to be quality assurance people or any of this. What we're really doing is we're teaching developers by giving them access to tools that have program rule sets that are created by specifically other teams. And that's going to give them a feedback loop. Because if you think about it from the DevOps handbook, and highly recommended, Phoenix Project is a good novel read on that. DevOps handbook, a bit more terse. And of course, the yellow handbook is one of my favorites because I like the guys who wrote it. Gene Kim, Jez Humble, John Allspa, and of course, Patrick Du Bois, the guy who actually created the DevOps hashtag originally. So the thing here is that No, developers are expected to be able to focus on what they're good at. That's the same thing. People say all the time, we got to knock down the silos. Well, silos for some things are actually very relevant. You cannot take all of your quality assurance people and embed them in Scrum teams and expect that they're going to become triangles at quality. Same thing with info security, your data management teams. Developers need to be able to focus on being great developers, and that creates a silo of talent for development. The silos that people want you to knock down are the silos of communication between business units and between people who don't use consistent patterns to do similar or the same task across the organization. Best automation tools for e-commerce apps. Selenium and SOAP UI, I would like to get your view on that. So I like Selenium and SOAP UI both. I think they're both very useful tools. I think the issue that you run into with a lot of these tests is that for Selenium is a great example. So if you think about this, and of course, welcome to the DevOps community, and microservices a piece of that in my world, and of course the architecture community. If you're already there, perfect. Development community wrapped around it, but I tie it all back into either a digital transformation or DevOps as far as all of that in terms of welcome and welcome. Because why? So if I'm going to actually use those tools, the key is that for the tests themselves, I have to basically break them apart. So I love the idea of e-commerce, because if you think about it, a lot of people will write Selenium tests that this test adds something to a shopping cart, then this test exercises some features of the cart. We then go into, account management and order management and the rest of it. But really, we need to break those tests apart. And really, the only way I find to do it is that I have different starting points. So essentially, I tie Selenium to injection. So, and that's, a really great ask, because a pattern that I've seen across a lot of very large, not only retail, but e-commerce platforms, in terms of, so instead of having to rely on the shopping cart functionality for the order, I'm injecting information directly into my data model as the first piece of my order testing. And the more I can inject data or start from a midpoint through that use, and there's lots of different tools that will actually allow us to do some of that tied to our Seleniums. And I like Selenium. I think there are other tools that do similar functions. It's all about, if Selenium is the choice, who's going to manage it? A lot of people, in organizations have a quality team doing Selenium. So now we've got, quality people becoming programmers, and I think there's nothing wrong with that. I don't know that everybody in the world becomes a programmer. That to me seems kind of risky. There are dependencies between services, but we're talking about services that are running in containers and able to support high volume transactions. And of course, we're sending them, they're doing a smaller bit of the puzzle, and we're sending JSON messages between them, similar to what we would have had to do in serializing, data in a database anyway between some of those steps, because that, in a servlet model, we'd be serializing data, and then we'd be acting on it between a coordination of servlets in a J2EE world, DLLs possibly, and object methods in a C++ or C# world. There's going to be performance impacts, and of course, that's why we need tools to be able to measure them. So great question. Multiple microservices, of course there is a disadvantage, because here's the thing, is now the disadvantage of having multiple microservices is that I now have to move those services and everything else in terms of regression. Anytime I change a database, anything that's tied to that database likely has to have some form of regression test. If I'm making a change to microservices that have significant data impact, or have changes in a data model, I'm very likely going to have to regression test everything that's in that shared database. Which language is best to write? No comment. Which language is best to write microservices? I love that question. I'm going to have to say, again, I I have my favorite, but that's strictly an opinion. There is no such answer to that question. It's going to be based on the skills in the organization. So I know Java, and I know Go, and I know Groovy, and I know Node as my probably my primary, and Python, I guess. So I could write microservices in a number of different ways. Now, would I have choices? Yeah, if I had my choice, I'd probably write in Java. But I also know C#, so if I had to and I was putting something into a Windows environment, there is no one-size-fits-all, but it would be helpful if everybody didn't write microservices in 20 different languages. Because the idea here is that you get to some consistency. So if you're working in a group that's all people who know Java, my guess is you're going to write them in Java. If you have a lot of people who know Node, the folks who know Node would probably recommend Node. You know, everybody's going to pick whatever their favorite is. And so if there is anything, yeah, we'll make sure that we send out an updated PDF if something went wrong there. Is there any rule of thumb? Well, we had, I think we spoke to quite a few of them. Hopefully that covered that. There are latencies in IPC, any KPIs when we come to microservice delivery. Well, yeah, of course, there's key performance indicators in everything in the world. But seriously, what are they for you? It depends on what you're doing. Like KPIs for microservices is how many containers do I need? You know, what is the response time for a request? It's a lot of the same kinds of things. I mean, we're talking a microservice. It's going to have a request and a response. How long does it take to get the response? How fast can I actually generate it? What is that latency? What is the, you know, when I start to measure, of course, I'm going to have tracing across all of this because I need to have a common, you know, telemetry. And of course, that comes back to something I mentioned early on. You know, we need to have telemetry in this because the KPIs are going to be, the KPIs for microservices are in so many different areas because it's down to personally what it is you're doing. You know, if you're a leader, the KPIs for me are how much money are you saving me by using microservices? You know, because if you aren't saving me any money and you're just making it more complicated and I've got to, you know, I'm reducing my software licensing, but then I'm also increasing my support some other way through, you know, through any number of different patterns, all of those things I have to take in count. I'm not sure what happens with the recorded link. Usually we play that, we put that on our website, so I expect they'll send it out. Do we have examples of applications that don't lend themselves to conversation? Well, I think they're, well, literally, how about RPG? I don't think most people would think that you could take an RPG program and turn it into a microservice. Now, having said that, it's not that out of scope to think that I couldn't even break some of these larger programs that are running in monolithic, you know, Z-series, I-series, VAX, whatever, you know, main mid-frame environments you have and do something there. So that's all possible. Because, of course, with every notion of complexity, there's something that we can find from that. How much minor level could build microservice? Well, I think the thing is a microservice should be doing something, right? It's there. The thing with microservices is we can have reference services like provisioning and some others that, but we're not breaking it down so that the microservices. I'm not going to have a microservice to add the number 1 plus 1, and then another microservice to add the number 2 plus 1. You know that. I mean, there has to be, like anything else. This is iterative. So microservices, if you think about it, people have a lot of services already built into many of their, you know, SOA-based applications. Those should actually map back out to microservices in many cases. Dashboards, well, dashboards themselves, I mean, Jenkins is a dashboard. Kibana is a dashboard in Elk Stack. Elf has a different dashboard. There's Gdash for other organizations. It's really, so the recommendation is really what is it that, two things. What is it people within your organization are using? Because people are already using Kibana, I know that. And I'm not sure what else. And of course, people are using Jenkins. So those two things I know people are using for dashboards. what else is there? I guess I would have to ask. I mean, at some point, somebody in the organization has to take on the task of doing the inventory, right? So if you're going to move everything you have in a pattern, then, hopefully we've got the CIO on the phone today, or the lead architect for innovation, or whoever the director is who owns that, or directors, and they're saying, hey, you know what? That's a good idea. We should probably inventory what we have. Oh yeah. I mean, this is basically what it really brings new is microservices wrapped in containers are componentized virtual applications, and that's majorly new. And the idea of black box that feeds logs into some centralized system so that I can eat them with Hadoop is not brand new, but quite honestly different than the way most people build applications. And the idea of trying to break out these services so they're not running on a Fuse or a TIBCO or a WebSphere ESB, and they're running separately so that they're not having, a single point of failure, or this need to have a $50 million a year investment in an enterprise service bus to run all my services. All of that is part of it. So it is a bit different, I would say. Having different databases is definitely going to impact, Yeah, I mean, the thing is, just think about it intuitively. If I have 5 databases, the idea here is how can I make it so that I don't need to have 150 people involved to move a piece of an application. So if I can have 5 people involved that only have to worry about one database, or one portion of what was a database, I still have to be able to break that up. It's a complete reference shift. I mean, somebody has to take one of your large applications and architect how you're going to break it up, because what most people start with microservices and Kubernetes and the rest of it, they start with greenfield. They build a greenfield app, and then that becomes the reference, but there's way more apps that have to be modernized than there are greenfield things that sit, by the side. All right, so I think that is all of my current questions. You are very welcome. I got a few thank yous in there, and so, I tried reading back everybody's questions as we were going, so that's great. Oh, you're very welcome. You're very welcome. And again, if you have questions, additional questions, you are more than welcome to reach out. Again, I don't answer my LinkedIn questions usually in the first 5 seconds, but once in a while I'll hit that. But I always try to answer anybody who asks me questions through that mechanism. So, hey, I appreciate it, Victor. That was very nice of you to say. And Sandeep Tal, that's very nice. Thank you. Wow, there's a lot of thank yous. I love to see that. That's great. And again, like I said, feel free to come back. Again, I'm George, and it's been my pleasure to actually spend some time with you today and talk about microservices. We'll be sending this link out to everybody, I'm sure, because no surprise, we like to share. And of course, once we get your contact information, most likely somebody will come back, because I believe we're rolling out a much larger microservice training program that's going to be a number of days of hands-on lab-based technology. And I believe that's coming in the first session, I believe, is in the second week of January. So for sure, ask your leadership, find out what the plan is there, and move forward. So good. Hopefully I'll be part of some of those as well, and I look forward to meeting more folks either in person or virtually, depending on how we do it. And again, thank you very much. I'm going to go ahead and cut the audio for now. If there are any more questions, I'll sure type back in. And I appreciate your time today. So happy Friday. Have a great weekend. Happy holidays to everyone. And again, hopefully a great weekend.